We continue our series on hyperbolic functions. In this session, we shall look at the derivative of the 6 basic hyperbolic functions. Let's start with the first one. Hyperbolic sine x. We know the hyperbolic sine x can be written in the exponential form as e power x minus e power negative x all over 2, or better still, half e power x minus half e power negative x. So to differentiate this expression, we can replace the sin s with the exponential form. So y will equal to half e power x minus half e power negative x. Then we differentiate term by term. Our dy dx will be equal to, when we differentiate e power x is the same thing, so we'll still have half e power x. But in differentiating e power negative x, we'll first work with the exponent. This is the function within a function. So we differentiate e power negative x, and that will give us -1. I will multiply it by the coefficient here, and to give us positive half. Then we differentiate the whole e power negative x, and it will be the same thing. So simplifying this expression, we are going to get e power x plus e power negative x all over 2. And this is the exact definition of the hyperbolic Cosh. So we know Cosh x is equal to e power x plus e power negative x all over 2. Hence, we can conclude that the derivative of sin x with respect to x will give us cosh x. So we should keep this in mind. As the lesson progresses, when a problem is given, we will not be required to go through all these steps to arrive at cosh s. This series is to let you understand how and why the derivative of sin x is cosh s. We should keep this to memory, so that when we have complex problems which combines a lot of trig identities, we can actually do them without necessarily going through these steps. Let's look at the second one. Y is equal to cosh x. We can change the cosh s to its exponential form. We know that the hyperbolic cos x is defined as e power positive x plus e power negative x all over 2, or otherwise half e power x plus e power negative x plus half e power negative x. Then we differentiate this expression term by term to see what value we will get, or what expression we will get when we differentiate cosh s. So in differentiating the left side, we have dy dx. Then when we come to this side, differentiation of e power x is the same thing, so that will give us half e power x. And when we want to differentiate e power negative x, we'll differentiate the exponent and we'll get -1. Then we'll multiply it by the half, which will translate into -half. Then we'll differentiate the whole expression, and that will give us e power negative x. Simplifying this into one form, we are going to have e power x minus e power negative x all over 2. And that is the exact definition for hyperbolic sine. So it means we know that sin s is equal to e power x minus e power negative x all over 2. Hence, we can conclude that the derivative of cosh s is sin s. So when we differentiate cosh x respect to x, we are going to get sin x. So we should also keep this. In fact, this is the basics. If you remember these two, then we can do other derivative based on the knowledge of these two. We shall look at the remaining four hyperbolic functions. Let's look at tan. We will use the idea we got from the cosh and the sinh to obtain the tanh. We can write our tanh x as sinh x over cosh x. Then we use the quotient rule of differentiation. You know, if y is equal to u over v, where u and v are all functions in x, then our dy over dx by the quotient rule is v dot du dx minus u dot the v dx all over v squared. So in this regard, our u is equal to sin x, and when we differentiate u respect to s, we'll get cosh s, and our v is the denominator, which is cosh x. When you differentiate v in respect to x, it will give us sin x. Then we throw in these guys into the formula that we have written above. So our dy dx will be equal to our v, which is cosh s, multiplied by the du dx, which we also obtain as cosh s. Then minus u, which is the numerator here, which is sin s, multiplied by the v dx, which is the same thing as the u, sin x, all over v squared. So that will give us cosh square x. Then we simplify the numerator. That will give us cosh square x minus sin square x all over cosh square x. The numerator is an identity, and we have already worked on the identities in my previous videos. So if you have not watched those videos, you can scroll up and look for those videos. Identities in hyperbolic functions. Cos square x minus sin square x is an identity, and its value is 1. So this becomes 1 over cos square x, and cos square x is also a reciprocal identity. We can write it as sech square x. So the derivative of tan x is sech square x. Let's put that 1,2 down. Keep it in memory. In the videos that will follow, we will not be following these steps to arrive at the sech square x. We'll just be using them direct. So you must commit them to memory. Let's go to the second one. We'll write this as 1 over cosh s. In fact, sech x is the same thing as 1 over cosh s. We can rewrite this further as cosh x all raised to the power -1. Then we can now differentiate term by term, but this one is a function within a function, so we'll differentiate as such by using that rule we'll differentiate the whole thing with respect to the content. Then we'll differentiate, multiply by the differentiation of the content. So we'll treat this as u raised to the power negative 1. And then we'll differentiate y respect to u, which are going to get negative 1 u raised to the power negative 2. So that's how we are come to treat this. So our dy dx will be equal to minus 1, then cosh x raised to the power negative 2. Then we'll multiply it by the content. In multiplying by the differentiation of the content. And when you differentiate the content, you are going to get sinh x. So this becomes negative 1 over 1 cosh. Let me write it well. Negative 1 over cosh square x. When this one becomes comes down, the power becomes positive. Multiply by sinh x. Multiply by sinh s. And this becomes negative multiply by sinh s. We can write this as negative sinh x over cosh square x. This can also be rewritten as minus sinh x over cosh x multiplied by 1 over cosh x. And then sinh x over cosh s is the same thing as minus tanh x. And 1 over cosh s is sech x. So this becomes the derivative of the hyperbolic secant. This is a derivative of the hyperbolic secant. So let's take note. Let's move on to the next one. We shall be going to the hyperbolic cotangent. The hyperbolic cotangent. The hyperbolic cotangent can be written as y is equal to cosh x over sinh x. And like how we did previously, we are going to use the quotient rule, which is y. We'll express this as y over u. Y is equal to u over v, where our u is the cosh x and our v is the sinh x. And by that, our dy dx will be equal to v dot du dx minus u dot dv dx all over v squared. So our v is sinh x. Then differentiating the u, du dx, we'll still get sinh x. Then minus u is cosh s. Then dv dx, that's differentiation of sinh x, will also give us cosh x all over sinh x squared, or sin square x. Then this can be simplified as sine square x minus cosh square x all over sine square x. We can factorize negative 1 out, and we are going to have minus sine square x plus cosh square x all over sine square x all over sine square x. Okay, we know that minus sine square x plus cosh square x is 1 from the identities. So we are going to have minus 1 over sine square x, and this is a reciprocal identity which is equal to negative cosech square x. So this is also the derivative of coth x. Let's move on to the next one. Y is equal to cosech x. You can write this as 1 over cosech s. 1 over sine x, 1 over sine x, 1 over sine x. Good. Then we can either use the quotient rule, or if you so wish, we can make this one raise the power negative 1, and we'll differentiate as such. Let's use that one. That will look more simple. So this is sine x power negative 1. Then our dy dx, dy over dx will be equal to negative 1 sine x raised to the power negative 2 multiplied by the differentiation of the content, which is cosh x. The power negative 2 can be written as negative 1 over sine square x multiplied by cosh x. We can rewrite this as negative 1 over sine x multiplied by cosh x over sine x. When we multiply back, we are going to get what's at the top here. Then this is a reciprocal identity. 1 over sine x is the same thing as the hyperbolic cosech s. So this will be written as cosech x, and then cosh x over sine x is coth x. So we are going to have coth x here. This becomes the derivative of hyperbolic cosech s. These are the summaries of all the derivatives we have done so far. In subsequent videos, we shall be solving problems, and we are not going to go through the step-by-step procedures on how to get the derivative of these functions. Those problems will just replace the derivative of the functions inside them direct. So what one needs to know is to keep these derivatives in memory, so that when you solve the problem, you can just use them straightforward without going through the step-by-step procedure. The purpose of this video was to let you understand how these derivatives were obtained. Subscribe to my channel for such videos on hyperbolic functions. If you have any question or comment to my video, you can leave them at the comment section below. Thank you very much for watching.